Okay, welcome. Welcome to the last session of this workshop, to the panel session. I'm very pleased to open the session and to introduce three panelists that are on the panel. We have Onas from IBM Research. We have Ophir Pele from Western Digital, and we have Rix Cohenblum from Parasoft. The three are actually very experienced, both in development and research. They work in the industry, but they have publications, patents, and innovation experience, including many activities in the field, in the industry, and in academia. So I have presented to the panelists a few questions. Each was got some questions which relate to his or her activity, and they have received the questions in advance. I can that's not a bad practice, but I'll present the questions to you, to the audience, and to the so that once answers are provided, you can know what we refer to, and it would save us some time on reading loudly the questions. So let's start. If you wouldn't mind, with Ona. Ona, I would be happy to hear from you about yourself, about your research, maybe about combinatorial testing, which we do for so many years, and about the relationship with machine learning. So please, Ona.
Sure, thanks, Owen, and hi, everyone. So I'm a researcher at the Haifa Research Lab for IBM. I've been here for the last 16 years. My PhD degree is in software engineering and computer science from Carnegie Mellon University. And my current research for the last few years has to do with the intersection of software engineering and validation and machine learning models. So how do you verify what a machine learning actually is supposed to be doing? We call it the envelope of expected operation. Same as in control theory, right? You need to be aware of what something is supposed to be doing. And then how do you control that? How can you keep it within its envelope of expected operation? And how can you know when it strays away from that? And what can you do in terms of corrective actions? So you've heard a bit about that in the previous talk by Sam about using weak data slices for drift detection. And that's based on the technology we've been developing here called FRIA AI that automatically finds weak data slices. Okay, so that's a bit of a background. And do you want to go to the first question? Do you want me to just answer, or?
This, I just maybe briefly refer to it. I know you for quite many years, and I know that you were doing a large part of this period of time. You worked on combinatorial testing, tools, technologies, patents, and so on, which proved to be a very successful approach to testing large software systems. And the question is, once the focus is on data, how does it translate to data? Is it still relevant as it was for software, for regular software? And ML is somewhat different in this respect. So, what is the how does it apply?
Right. So that's a great question, and one that we've been actually dealing with for the last few years, right? So I'll just recap combinatorial testing in case there's anyone that doesn't remember what that is. So in combinatorial testing, you represent the space that you want to cover, that you want to test, as attributes and their values, or in terms of machine learning, it's features and their values, but it's all discrete. Okay. The features are discrete features. Then you do a Cartesian product, and naively you would want to test it all modulo impossible combinations. Okay, so if your space, say, the traditional world, you wanted to test an operating system on various types of hardware and network, then you would have that, but maybe you wouldn't have the possibility of a Windows operating system running on MacBook hardware or something like that. Now, it's been, we have lots of experience with that, and it's very effective. It's a very easy, simple way to model the space that you want to test, and people can do it well. So that's a good point. Now, when it comes to machine learning, it's actually not a trivial translation, okay? Because on the one hand, our experience is that this way of thinking about the space to test is a useful way. This way of modeling, of abstracting in terms of features and their interactions, that's a very useful way. But on the other hand, even though it seems like we have features, maybe it's a one-to-one translation, we can just use everything. Whereas traditional software has all this experimental evidence showing what is sufficient in terms of coverage, right? There is this NIST research results that clearly show for many domains over many different companies that if you take the interactions of just two factors, you already cover the reason for about 70% of the defects that you see in software. Right? And that's the basis for being able to reduce the huge Cartesian product space into something manageable and optimizing a test plan. Okay, so that's the basis for being able to work with combinatorial test design, to do combinatorial testing. And if you take even just 5 factors and their interactions, you're well over 90% covering the source of errors. Okay, so for traditional software, we know that really usually the reason for defects are when you actually debug it and you check it, there is a small number of interactions that's responsible for that. Now, how does this translate to machine learning? There's no evidence around that, right? So all the coverage metrics that apply do not apply in the case of machine learning. And what we've been doing is taking this approach of looking into the factors that seem to be responsible for having many errors. Okay, so that's the weak data slice. There are many additional ways to look at that, where the underlying question is coming up with coverage metrics, right, that apply here and having evidence to their effect. Okay, because there are fundamental differences, right? If for traditional software, what you want to do is to optimize the test space. You want to run as few tests as you can, and the results are usually deterministic. To run one test per combination, and it either passes or fails. For machine learning, when you have a machine learning model, it's okay if it fails sometimes. It can still be, performing sufficiently well. And the question is, how do you decide? It's failing too much, right? And to do that, you need to bring in statistics. And to do that, so it's almost as if it's the opposite of the traditional test optimization. You want as much data as possible, but you need to understand, sort of aggregate the errors, right? What are the reasons for the errors you see? Maybe it has to do with subpopulations that are not being handled well, such as people in the ages of 35 to 45 that live in the East Coast or the West Coast, and they're not getting loans approved. Okay, if it's a loan approval type of machine learning model. So, again, in terms of the challenges, we need to bring in this empirical evidence, showing that we can really combinatorial thinking here and look at a subset of the affecting factors. Okay. I think that's the main reason. Another thing is that the more interactions you have, say I want to look where the age range is a certain range, and the number of years a person studied is a certain range, and where they live is a specific location, and so on. The more factors I add in, the less likely I am to actually have sufficient data to do any statistical analysis. Okay, so and it becomes less clear, what the reason is, what's going on. So there's this trade-off here. We clearly see it, but we need to build the evidence behind it to become as mature as it is for classical software.
Okay, I think this was an interesting observation of the ways in which one technology translates to a new domain. And I think at this stage, maybe we should proceed to the next panelist, to Ophir Pele, and we'll reserve the questions for the last part of the session. So thank you very much, Ona. Ophir, the questions here on top are actually for you. You've seen it in one way or another. And I know that you actually, in your background, you have done so many different things. You are a researcher that is interested in everything, it seems to be to me. And you do so many interesting things, but diverse things. And in your daily job, you develop some algorithms, I believe, but you actually explore so many things in your research. So I've seen that some of your recent studies focus on diagnostic, on medicine. Actually, it was interesting to me because I've also done some research. And in fact, what I'm concerned about when you do some research and you find some ways of using machine learning for the diagnostics, one of the concerns is that, what if the machine is wrong? What if we do errors in our machine learning, and then we need to treat people based on these results? It's not that okay, the model has made an error. It's someone should be treated based on that error. So this is kind of a very high risk of the outcome. So what can we do about it? How can we increase accuracy in such cases, or can we not? I don't know. So I'll let it's for you to discuss it and provide possibly some answers.
Okay, thanks. I'll first introduce myself. So I'm working now for Western Digital for the last 4 years as an algorithm developer. Before that, I was an assistant professor at Ariel University. Before that, I had 2 years of a postdoc in UPenn with the late Ben Tasker, and I did a PhD in the Hebrew University. And if I can think of one line of the work that I've done is how to make models that you can inject human knowledge into them and not just throw data at. And specifically for your question, you're referring to a project that was done about diabetes. And the story of this project started when a colleague of mine had a talk with me that she had a daughter that she has diabetes type 1. And she has a machine, and she was doing actually machine learning by hand for her daughter. And she was able to stabilize her. And she didn't work at machine learning. She was doing theoretical learning about property testing, about networks, about stuff like that. And she told me, can we do something better than this, and not just for my daughter, for everyone? And this is how this project started. And the question whether we are doing errors is a valid question, but we have to remember that in many cases we are doing something. We are not calling it machine learning, we are calling it something else, but in many cases it is machine learning, or it is handcrafted machine learning. And then you can move to machine learning that just throws data and starts to find something, or you can do a machine learning that is very, very restricted. And then you can lift the restriction one by one and get a model that is explainable. And this is where it is hard to do it, right? Because you need to know how to inject the information. In many cases, you don't have tools yet that were done for that. I can give one example, one new example. There is a group in Google that is called Glassbooks of Maya Gupta, and they have models that I call lattice models. And they are very interesting for me because I actually also developed them for a different reason. I developed them for metric learning, how to learn distance functions that have some kind of properties. But also you can enforce properties such as monotonicity. And think that you know that this function should be monotone with respect to this variable. The doctor knows that this is right. So if you train a model and the model is not monotone, then the doctor will throw this away, and it can have catastrophic disaster. But if you inject this prior knowledge and it is monotone, and you know that it's monotone and it's not, I don't know, the gradient is not too high, you can inject all the prior information that you have and the data knowledge that you have. Then you can have a model which is both safe and explainable, and you can actually use it.
Okay, so actually, if actually, firstly, it's very impressive that it was as a result of an actual issue, and the health of someone was both a motivation and also given a solution to some extent, I believe. And I see your point. I mean, there's a, you said that if there's a good way to inject the actual read information into the model, you can actually provide the guarantees that we seek. Maybe not always, but at least in large part. I think that's an interesting approach. Actually, just as an immediate response, I will adopt this into my solution. Motivation for the question was a research of mine, which also looks at diabetes from a different direction. It was initially looking at acute stroke, but also at diabetes from a different angle. And what you say could actually improve a lot what we are studying. But I'm trying to look at another angle of, because of the diverse experience that you hold. Can we actually use machine learning and deep learning in particular or maybe let's see to test medical software that we have, because today the medical software that we have, we are surrounded by such software. So can we use those technologies to actually improve those systems, not just by doing diagnosis, but maybe improving the software that we use there in a way, not the medicine itself, but the software. Do you have an opinion on that?
Yeah, I think it is possible. I think that we've seen today all kinds of methods that you can take also to the medical approach, like the talk that we had from Facebook of creating bots. You can create simulations of humans to see what happens and to see that if somebody will have some kind of properties that we didn't see with the normal population, then the model won't freak out, and create something which is totally different. Or you can also inject prior information by having the ability to say, we are out of distribution, then for this model, we don't know what to do exactly. So we'll do something very conservative or something like this. I think it's a very good approach.
Maybe this actually ties to the presentation by Ona's team beforehand. Out of distribution is something that you study a lot, Ona, don't you?
I think it's a very interesting topic, and being able also to insert prior knowledge, and being able to suggest, is that something you forgot maybe, right? We're seeing this. Is this the way it's supposed to be happening, and how do we bring that in, right? Having a way to incorporate that in the learning process. That's another challenge.
Yeah. Please, Sophia.
Yeah, I really like the idea of looking at slices of the data afterwards, the free AI, I think it was called, that you look at and you have the model, and post the development of the model, you see the things that happens there. I think it's orthogonal to workers that try to inject the information priorly. And it can give you very good insights, like talking about the medical doctor can look at it and say, this makes sense, but this does not make sense, or something like this. We need to gather more information here, or any other idea.
Absolutely. And there needs to be a way to feed that back, right? The ones that do make sense.
Yeah. If we can close the loop of injection this information, that this needs to be monotone, or this needs to be shaped like this, or something like this, it makes total sense. Yeah.
Can I see a project coming after this workshop? Anyway, I think there's the much mutual contribution of those approaches to one another. So there can be something new that would evolve from here, something more useful than we do today, or better than we do today. I mean, we do useful things, but it could be maybe even further improving what we do.
Absolutely. Also, the Spark Beyond work by Amir Ronen. That's another way to suggest knowledge, right? To mine knowledge and suggest it. That was really interesting as well.
The approach that Fabian is taking for a few years now is very interesting. It really generates things that we usually do not generate from in machine learning. They go to the web and they gather information and they create textual features which we usually do not use. But that's really seems to be successful because they have business space on it. If people are willing to pay for it, likely it has some value.
That's another version of the pre-existing knowledge, right? That's they go ahead and they suggest knowledge that no one encoded as a feature, and they suggest it to you as another feature.
How are we doing with time? I think we are still okay. Yes, we are fine. So I had one more question on this for you. I'm not sure whether you are dealing with this in your either research or practice of here, but I was referring to the fact that that could be actually there were attacks against medical machine learning, and since we know that the machine learning can be attacked, maybe in the same approach that you have suggested, is there other preferred ways or different ways to protect against an attacks? We know the risk. I mean, one of I heard for some there was a demonstration of an attack in the context of diabetes, actually, an attack on the insulin machinery. There was a demonstration of an attack on the insulin machinery where they can change the dose and they actually can keep the patient by that. What do we do as a community against such attacks? That's really dangerous. I mean, people can kill you from remote this way. Really dangerous.
Yeah. So I'm not an expert in the cyber cyber defending, but I think you can, if your model has some kind of a safeguard against the feature and against possible action, then you can detect when you are under an attack, and then you need to do something else. It's a very good question, but I'm not an expert about this.
I assume that. I just say if by chance you have more knowledge on that because of the diversity of things you've done, maybe. But it's good to put it in the air so people would think about it.
Yeah, for sure.
Okay, so maybe at this stage we'll proceed to Rix. Rix is as I said, at Parasoft. He's a strategic innovation manager, and he has several interesting publications. Some of them on policy-based software development, and in this context, I actually had some questions. So maybe firstly, Rix, you would present yourself, and then we'll proceed to questions.
Yes, thank you. Good afternoon, everybody. Shalom. Nice to meet you. Very good to be on this meeting. Yes, I have a background in, let's say, the more formal side of software engineering, specification languages, theory proving, sort of more logic modeling of particular requirements, and then kind of to mathematically prove software is working. I think very popular approach in the 80s, the 90s of the previous century. But then I kind of professionally moved more into the more operational aspect, the software testing, with always had a kind of a more symbolic approach. So I look at the world as very symbolic. It started off more syntactically in the beginning of the century with the year 2000 problem. I mean, some will remember it. Anyway, it was of course a fascinating problem. And to develop algorithms, I think they were clever algorithms, not automatically machine learning, but clever algorithms to deduce with the data flow analysis. Could there be a potential data misuse of a certain field? And yeah, I stayed kind of in that world, and I work for Parasoft and kind of in two capacities. First of all, I manage the technical pre-sales team over here in Europe and the Middle East. So I even work with some people now of Fierce company to help them with compliance needs. And then you can think about medical, automotive, but also financial, in principle, critical software, either because it's safety critical, security, or just business critical. So that's more the operational side. And the more strategic side is that I manage indeed the innovations, particularly on this side of the ocean. And more recently, and that's also why I met a few people on this conference, we've participated as Parasoft in a European R&D project funded by the European Commission called Testom. It's really about how can we develop a next generation of test automation, because that's the field that Parasoft is operating, automating software testing. So that's maybe puts a little bit the perspective of where I come from, and also the look at the from a Parasoft point of view at the world. And I don't know if you already would like to go into that first question that you've asked on. Because you're right, particular in the field that I mentioned, the safety critical, it's very driven by compliance needs, and they go even that far that people have to stay within certain subsets of C or C++, because otherwise it's kind of too dangerous, or you will create memory leaks, and then sooner or later your car will crash or your medical device will not work. So therefore, as a world, we define kind of policy-driven software development, and then of course you need software from us or from our colleagues to enforce these policies. And for that, up till now we generated very much engines which are more mathematically based, kind of brute force, either pattern matching or data flow analysis of source code. And within that capacity, we see a kind of movement also within our own R&D, where we took a very serious look at definitely machine learning, and we have maybe some touches of also deep learning, on what can we do to improve the engines itself. And so think about, in the end, it's also a combinatorial explosion of the number of paths you can do. So at a certain moment, you have to make intelligent cuts. So besides doing them mathematically, maybe we can also, based on machine learning, make sure that the engines that we have calculate through the most interesting path in a piece of software. For example, finding security problems in code, or resource leaks. And that's very operational. That's how to make our own engines internally stronger. But the most recent also of which we were able to publish some results was also to help the end users of our tools that can sometimes get kind of overwhelmed with a lot of findings. And in principle, these findings are correct. It is a violation of the coding standard that you adopted, or the one that you had to adopt because you work in a certain kind of industry. But of course, how to work yourself through as a human, as a developer, through all these findings. And there we've had very good results with using machine learning techniques, supervised learning techniques to, for example, which one have you fixed frequently? And I think that comes a little bit also one of your questions. Can you help machine learning with defining a policy? So that policy could be, well, based on what your team has been doing, or maybe what other teams in your organization have been doing. They've always fixed these type of findings, and the other ones they declared as false positives or suppression or that kind of build up for technical debt for the future. So then you kind of implicitly learn which ones of mathematically computed findings have been always relevant to you. So that seems to be a very promising. And there also our experiments show that you only give them 10 to 20 examples, and then you already get a very good prediction of a kind of a ranking on where to start first, to make sure that you always fix the ones that you definitely wanted to fix in the past. Another effort is also, it's almost kind of personal, I like it a lot, is look similar. So there we have the ability, like if you have a defect, you know a little bit, oh, that is this type of pattern, I always use this class and then I forgot to do this. So that the tool then suggests you, well, if you start to look at this particular instance, then probably also want to look at the other ones because they are kind of similar. So kind of your mental energy that you need to fix one is kind of preserved, because once you're in that fixing mode of these type of defects, then probably you also want to look at those because they look similar. And the third one that we've kind of prototyped, and it was kind of we call it hotspot analysis. That kind of, you would call it root cause analysis. So not root cause, but well, if you fix this one, you can automatically get rid of a lot of kind of secondary violations that are just the result of this root cause. So it's not directly data flow related, because then you have the real root cause. But if you remove this one, then also the other policy violations will disappear. So then you automatically will start now with the biggest bang for the buck, I think the Americans call it, so that you can very quickly remove the first ones, and then automatically, by removing them, get as a side effect, you remove the siblings. So that's kind of the more operational aspect where Parasoft is now putting machine learning in the tools that hopefully make the experience of our users, that you're right, that have to work in a policy-defined world, to make that a bit more friendly. And now I think I was intrigued with the just before the lunch break, we had this interesting presentation from the people from Sevilla, where they want to use API testing, because that's the other type of business that we do. Try to look at applications a bit more at a black box level, not only the code, but also black box. And then we take APIs or web UIs and try to do automated regression tests there. And in particular for security attacks. And that you can also there then kind of learn by, for example, observing, maybe even with something like simple like Wireshark, observe the behavior and then try to deduce certain patterns, unexpected behavior, or maybe actually this one always has been normal. We've tested it for this. These are normal users of the application. And if then suddenly we detect a different path, then we would say, wait a moment, this is strange. Either this was an exceptional case, which we never tested, somebody with 13 children. I mean, okay, that can happen, but that was an exception. So therefore, it's a false positive. Or that somebody is doing something kind of more abuse case, and that we found a path that could hint us to a security violation. So that's more on the API side, where you still have a very technical view of the application, but it's already something that is able to be executed. So that's kind of where we currently see now our use cases of machine learning. And with deep learning, if people have ideas, I'm very open to this. There you need, of course, a lot of data. Well, of course, a lot of code out there. But of course, you need to train it to not only have violations, but also a human interpretation that it actually, so a kind of a classified training set. And that is not always very easy. Often it's kind of implicit. People, you find a thing, and then if the next build of the software is gone, oh, then maybe people saw this as being a valid violation that they need to fix. So at the moment we kind of, struggle is a strong word, but we could do with good data sets that already have some training information, so we could also make the step towards deep learning. But that's kind of how I currently see and can summarize our machine learning efforts, particularly in the compliance-related world.
Okay, Rick, thank you very much. It was a detailed answer and very well understood, and gives another angle of machine learning in software engineering, in the industry, in fact. And actually, one thing that you were saying was very interesting to me to hear. You said that you have cases where you learn from 20 examples. It's not the main discussion, but it's just of interest, because one of the things that always keeps me curious is we human beings, we learn from a few examples. That's very typical to humans. We have 3, 4, 5 examples, and we know. And when we come to the machines and try to make them learn from a few examples, it's usually very difficult.
Mm-hmm.
As you have more examples, learning is becoming much better. But you said that in some cases you can do 20 examples, which is quite impressive. Is there any specific case where it happens?
Yeah, no, I think what makes our world is not that our world is better than your world, that's not that, but of course what we deal, we deal with pre-processed information. So at the moment we deal with findings of code. Code is very difficult. We also started just very brute force with code and just can we completely scratch. We live in a very symbolic world, of course. What can we do there? Now I mean, it was also naive, but okay, it's always interesting for us to try if you miss something. So that was actually not successful. Just look at the raw source code as ASCII. And then we went to the parse tree. Also that one does not contain information, but we know more. We know the programming language. You might even know the compilers. You already know more. So let's use that information. And I think, Ophir, I like what you said. Use whatever that you know helps. So put that somehow in, not directly the model. But of course, what we now we train on examples that were the result of a static analysis engine.
Okay.
And that's where we trained it. And then, now also kind of to our pleasant surprise, that about 20 times that you classify, say, well, this is something I like to see. This is what I don't like to see. I declare this as false positive. The next time you would get a very good suggestion, recommendation. It will not throw everything under the carpet, but it would, let's say, reiterate the order, which would in our tools and our competing tools as well, or colleagues, normally we classify them as 1 being serious and 5 being, compiler warning level. So that can be kind of independent, because maybe a level 3 violation is for you very important. Although if you just use the normal ranking, you will always start with the number 1 violations, and then time is out, and then you leave the other one thing. So then it kind of would reorder the violations kind of independent from the default ranking, just based on computer science. This is severe and this is cosmetic. So that's then where you see the gain and the improvement. Yes.
Actually, it ties very strongly to all of the other issues discussed here. Because, as you said in the morning, we heard Amir speaking about such issues. And then in Ona's team's lecture, and what Ophir was suggesting in his statements beforehand, and it all comes to one statement of saying, if you can find the right way to handle additional information, either you inject it somehow, or you extract it from the web, or you have some specific knowledge from software, but you know how to incorporate it, then you get a much better and much more accurate learning, more immune to attacks, more immune to drift, more immune to any changes or ways that would harm the result. So I think it complements the general statement of that, machine learning is not just putting everything into the neural net and getting some result. It's, if you want to do right or better, you need to do beyond that. And we have now different suggestions on how this can be done, in fact. So I think at this stage, I mean, we got interesting statements from each one of the panelists about the questions raised and about the specific ways in which they do machine learning or use machine learning or improve machine learning and to do some useful, to have some useful results, and both with effect on software engineering and effect on systems in general and on results in general. So maybe at this stage we would take some time to take questions from the audience, and let's see what I already have a whole list in the chat and see what we have there. We can get there. Let's see where it started. Okay, so we have questions from Vincenzo as following: in industry, how much the feedback from domain experts is still important, essential for ML-based software engineering? We have briefly discussed it before with Ona. So it's open to all of you, of course.
Yeah. Now, maybe if I can start, and of course, I will bring it directly to programming, because that's the world that we operate in. And we just recently talked to a very interesting question. I didn't even realize about this use case of our own technology. It was a large automotive factory that depends a lot on subcontractors, so subcontracting companies that also build components that in the end they will put in their final product, which they then have to give to their end customer, which in the end is us, you and I driving that car. Mm-hmm. And they were very worried about the style and the quality of each individual groups. So that comes to, I think, to this topic of how much is the domain experts. So we thought, okay, this will help you to classify. If you train this software, it'll help you to work and to make you work more efficiently because you fix the things you always wanted to fix. But they thought of, okay, if we do that, then we kind of cross-use that model to make sure that each individual group actually can be kind of compared if they've all been using and interpreting these compliance rules in the same way. If it still makes sense, what I say to you. So instead of only using it for, okay, let's make our own workflow more efficient, then say, well, actually we trained here kind of implicitly how these people always have developed the code. Let's use that kind of to where would it then react on the quality of another group to make sure that we have a kind of cross-group consistency of quality. So there, in a way, it comes to that point, then yes, it does get kind of trained how these people always do the work. And then maybe you can use that implicit knowledge to actually see if all the groups have worked kind of consistently. So you, now as an overall product, are a bit more assured that the whole thing is developed in a consistent way. So I found that an interesting angle. So there you kind of make use of the fact that the model is actually kind of tweaked to a certain industry domain experts.
Okay, and thanks, Ophir, Ona.
I think from my own perspective, I can tell that prior information is very important for many of the projects that I've done in the industry. In many cases, you don't have lots of data, or the data is changing with time, and you can't wait to gather data because it costs you money to gather the data, and you want to improve the production line, for example. You can't stop the production line for 1 month and say, okay, now we are gathering data for machine learning projects. You want to have results as fast as possible, and things change. The world is changing, so you don't have lots. It's not like in computer vision where you just want to say this is dog and this is not dog, and prior information of how dogs looks is not important because you can just gather data almost for free. So in real world application, in many cases, the data changes and you don't have lots of data, and prior information is very important.
Yeah, and I have to agree. Okay, and I said it before. I actually think you really must have. So we had 2 examples here from Rix and from Ophir for how the human can be in the loop, right? And how you get the information. And I think the human feedback throughout this is a continuous process, right? You're never done really developing or testing a machine learning solution because of what Ophir just said. The environment keeps changing, the data keeps changing, the distributions keeps changing. We only have partial information, and we can never fully encode all the prior information. These are the expert systems, right, from the 80s. So we have to find the balance here of how do we take the information that does exist and put that in, and also how do we utilize the human expert to give us feedback as to what is right and wrong, with what is happening currently, where we don't have any relevant prior information, when we're out of distribution, right? Is that the new distribution now? Should it be in distribution? Is it still out of distribution? And we need to get all that information in a way that the human can actually respond. They need to understand, they need to be able to make a decision. The mathematics of the learning itself need to be able to take that into account. And it's part of it is also because of what Ophir said. It's also not the case that it's any one of us that can provide the truth, like in the dog and cats example. We all know what's a dog, what's a cat. But if you have a tumor and the task is to decide whether it's benign or malignant, you really need the radiologist there. I wouldn't know what to say. So we need the humans in the loop, and we need to be very, very clever about how we involve them and keep it to a minimum, have it ongoing, and as much as possible also in advance, whatever we can do. That's the way I think of it.
Thanks. Actually, I would like to add my 2 cents here too for my machine learning experience. Two cases in the last couple of years that I was working on. So one case I was working with a cybersecurity company, and they were saying, we don't want to find the virus. We know how to find the virus. We want to find those machines that possibly would attack us in the future. They never attacked us before, but we want to find out whether they will attack us in the future. What's the chance of that? And we have a few millions of machines, and we don't know which one is the suspect. Can you help us? And say, okay, you do have data. I say, yes, of course, we have so much data. We don't know what to do. So they gave me a whole huge data set with thousands of features there. I said, oh, thousands of features, what do I do? And then I needed the experts. I told them, I can build a model, and it would compute and give you, these are the 200 features that affect your result, but I have no idea whether it's important or not. And we did some work with number crunching, of course, but eventually, without the experts of theirs, we couldn't say anything useful. Really, nothing useful would have been there without them. So we just made some number crunching, went back to the experts, asked them, does it mean something to you? Is it really saying something useful? Getting some feedback, going back and forth. And this was the only way to get to useful results. And eventually we ended up with less than 100 features which are of importance, but it was very difficult to come up with this list by ourselves without feedback. And we had another thing which was in medicine, which without the doctors from the hospital, we wouldn't have been able to do something useful. Because I have no idea. I know machine learning. I can do number crunching, of course, but it says nothing. Neural net, put the data, get numbers, so what? So you need something in addition to that, at least as we do machine learning today. Maybe in the future, the machine will be so smart, it will be able to get it, go, learn, do whatever you understand, tell us what's right. But not today, not yet. We're not there. Okay, let's see. Do we have other questions from the audience? We still have time for questions. If you want to ask questions, we can get the questions. If not, we don't yet have other questions from the. Oh, we have one from Gunnar. Okay, let's see. I need my glasses for that. Has any of the panelists applied explainable AI techniques in their practice? What is their general opinion of such techniques? Okay. Feel free to answer. Have you done that?
I've done that on a monotone function, as I said, and it's very important. It's really it really improves the adoptness of the method, and also it works. This is what I have to say about this. And I see another question that we actually skipped is the one about what maybe the prior information will bias the ML software training. So it is possible, and this is the part where you need to take the information with a grain of salt, right? You need to decide whether this is true information or whether this is like something that, okay, we thought that this is the way that we've done it by far. We don't know why. So this is a prior information that I will be skeptical about it. But if you know that this is the physical property, this is the prior information, it's a physical property, you know it. You saw it in millions of experiments, you have lots of statistics about it, you know the mechanism of it, then this prior information makes sense and you should use it.
And this is actually where the post-training analysis, such as the weak data slices of FreeAI, can help. It cannot resolve the issue, okay? It's a big issue, it's always there. But it can show you areas where you're having problems. Okay, and we've also done weaknesses according to densities. So also areas where you have too few data or no data at all. So therefore, you cannot expect to make any database decisions from that. And also areas for which you see underperformance and much higher than expected error rate. Right? And that might be an indication of bias. And that goes after things you haven't thought of, to begin with. Okay, so normally bias is for predefined features, right? So you can think about that and test those, but you cannot test the entire space. So, a bit of that is done with a post-training analysis. But we've seen many examples of people not even being aware of their biases until they see the results of a machine learning method. So it's always there as well.
Okay. Any more responses? Okay, so let's. At this point, we have no additional question. However, we are about to finish our session anyway. So, firstly, I wanted to thank you, the panelists, for agreeing to serve on the panel and providing so insightful answers to the questions, both those provided in advance and those which were asked during the session. In my mind, it was very enlightening to listen to such, to learn from what you have to say. And I hope, as I said during the discussion, I see some things that can be actually can become some new opportunities here that can result from these discussions, and maybe something will indeed be the result of this. And this is applicable not only to us, but to anyone in the audience in the workshop. Maybe you learn something that is calling for an answer. So we need to do something about it. That's what we do as researchers, isn't it? Try to solve new problems. And let's maybe sum up. I'll share again. Again, I cannot share what I shared before. I don't know why, but let's see. Anyway, so let's see. No, it does not share the screen, so I'll proceed without sharing. I have some sharing problem, but that's not an issue. So we'll wrap up without a presentation. I wanted to again thanks all of the participants of the workshop today. We had a very rich, interesting program. I hope we all learn from it and we're able to hopefully next year meet in this new edition of this workshop, but face-to-face, hopefully. It would be a big difference. We have more than a year of the COVID-19, and hopefully this is going to be going down. Over here in Israel, it's already a very good situation. So in Europe, it's improving as well. I think the in the US also the vaccination helps a lot, and hopefully in a few months it will be behind us. At least we hope. And I wanted to remind all of the participants that we do have a special issue with the EMSE, empirical software engineering. Is it the name? Yeah. And the special issue relates to the topics of this workshop. Papers that were presented here can be revised and extended and will be reviewed. You can submit it to be reviewed as usual for the journal, but others that would like to submit, we encourage that. It would be a regular review process of the journal, but the topic is surrounding the topics of this workshop. So if you have some publications that it's a very good journal, if you want to publish there, that's an opportunity. So really encourage that. You can find the link to the call for the special issue and to the details on how to submit and what the requirements are at the website of the workshop. So you are most welcome to submit. And we thank you again for really a very interesting day, a very very promising directions, and we hope for more such research to proceed. We'd love to hear from you in the future. And if you have any questions after the workshop, please don't hesitate to email us or contact us in any other way, and we'll be happy to respond as you, whatever question you have, we are happy to respond. So thanks all. Thanks again. Let me clap my hand this way, not the virtual way. So it was really a very very fruitful day, and thanks again. So we are closing the session. Andrea, do you want to say anything, or just I've seen you clapping your hands, so maybe I'll find it. Thank you very much. Thanks. Bye bye to everyone. Have a great day and continuation of the conference if you attend other events. Bye bye.
Bye bye.